the Tennessee's at-home learning series for math. Today's lesson is the 19th lesson in our series. It is for all 5th graders out there, though all children are more than welcome to tune in. My name is Miss Williamson, and I'm a 5th grade teacher in Tennessee schools. I am so excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them at the Tennessee Department of Education website, www.tn.gov/education. If you haven't seen those lessons, you may want to go back and watch them first, as we will be building on what we learned previously, but you're more than welcome to tune into today's lesson if you'd like. Today we'll be learning about how to apply formulas for volume in order to solve a problem involving the volume of a rectangular prism. Before we get started, to fully participate in today's lesson, you will need paper, pencil, and a surface to write on, or you can find your student packet for grade 5 math, lesson 19 at www.tn.gov/education. I'll give you a minute to gather your things. Okay, let's begin. In the previous lesson, we learned about using the area of the base of the rectangular prism and multiplying it by the number of repeated layers. Today, we'll continue working with rectangular prisms, and we'll be using a formula to find the volume. Let's start today's lesson with a warm-up problem that will help us make some connections to what we already know about volume. What do you notice that is different about these two rectangular prisms? Yes, one is composed of 1-inch cubes or unit cubes, and the other is not. Great observation. What is the same about these rectangular prisms? You are absolutely right. They have the same dimensions, 3, 3, 4, 4, 4, and 4. What does that mean? Will they have the same volume, and why? You're right, they will have the same volume because they're the same size. Excellent work. You might remember that we learned that by using the area of the base and the height and multiplying, that we could find volume. Looking at this diagram, I see that the base has a length of 2 and a width of 3. And so to find the base area, I know I need to multiply. The base equals 2 times 3. And so my base area is 6 centimeters. I put a 2 and a 3, and I needed a 2 squared. I also noticed on the diagram that there are 3 layers. That means that my height is what? That's right, our height is 3. And so to find the volume of the entire figure, I can do the base area times the height to give me how many unit cubes would make up that figure. 18. And so we would say the volume of this figure is 8 cubic centimeters. Now let's solve another problem together while we continue our learning. Looking at this diagram of a rectangular prism, as we read the question, Mike is making a box to hold his favorite DVDs. The length of the box is 7 inches, the width is 5 inches, and the height is 3 inches. What is the volume of Mike's box? Well, we said today's focus was on using formulas to help us find the volume. And so let's look at this formula first. This formula says length, volume, equals length times width times height, or V for volume, L for length times W width times height, H. Now, because of the commutative property, the order in which we multiply the dimensions will not matter. but labeling the dimensions can help us clarify the formula. So the base of the prism, we usually consider the bottom of the prism, the length and the width, and we usually consider the vertical dimension, or the up and down, the height. So let's see if we can identify those for this problem. Using Mike's box, we can say the length is 7 inches, the width is 5 inches, and the height is 3 inches. Do you agree? Excellent. And now we know that the formula says we can multiply the length and the width. So what is the product of 7 times 5? The product of 7 times 5 is 35. What does 35 represent? Yes, you're right. The 35 is the length times the width, which is also our base area. Good job. Now, the formula also says that after I do length times width, I need to multiply it by the height. What is the height of Mike's box? 3. And so 35 times 3 should get me the volume of the entire figure. 3 times 5 is 15. Regroup a 1. 3 times 3 is 9 plus 1 is 10. Did you get a volume of 105? Excellent. Do we just say 105? No, you're absolutely right. We say 105 inches cubed because we measure volume in cubic inches. So for this problem, we use the formula length times width times height, or 7 times 5 times 3. Fabulous work. Now, this is not the only formula we can use. Since we know that the length times the width is our base area, we could also use this formula. Base area times height. You'll notice in shortened form, it does V for volume is B, base area, times the height. Well, using this formula, instead of 7 times 5 times 3, we would have had 35 times 3. Are you seeing the connection between length and width and base area? I sure hope you are. Now let's apply this formula to a similar problem. Emilio's family has a sandcastle kit. The kit includes molds for several solid figures that can be used to make sandcastles. One of the molds is a rectangular prism like the one shown at the below. How much sand will it take to fill the mold? Let's think. The problem is asking us to find how much sand it will take to fit the space inside of the mold. What will we be measuring? What is the space inside of a mold? Of course, you're right. We will be finding the volume of the mold. For this problem, we're going to use volume equals base area times height. Volume equals base area times height. Well, do you remember how we find the base area? Excellent. I heard somebody say, Ms. Williamson, we find the base area by using the length and the width. So let's identify the length and the width of this prism. What is the length of this prism? 5 inches. What is the width of this prism? 4 inches. Fabulous work. And so, what's the base area of Emilio's prism? The mold. Good. I heard somebody say the base area is 20 inches squared. Now what do we have to do to finish solving the problem? Good. We need to identify the height. What is the height of Emilio's prism? Yes, you're absolutely right. The height is 8 inches. Well, when I'm just looking at the bottom, remember that's two-dimensional. That's where we got the 2. And now that I'm adding the height, what am I doing to the measurement? I'm making it three-dimensional. Good. So now I need to find the volume, I do the base area of 20 times the height of 8. What is the product of 20 and 8? Good job. 20 times 8 equals 160. So remember though, we measure volume in what kind of units? Cubic units. So I don't want to just leave it as 160. I want to say that Amelia's sandcastle mold has a volume of 160 cubic inches. Fabulous work. On this problem, we use the formula base area times height. But remember, how did we find the base area? Good, I heard somebody say it. We found the base area by first multiplying our length and our width. Great work. Let's look at some other examples together. Are you ready? Cindy is making a box to hold her favorite beads. The length of the box is 4 centimeters, the width of the box is 4 centimeters, and the height of the box is 9 centimeters. What is the volume of the box Cindy is making? Well, to find the volume, we first need to identify what's the length, what's the width, and what's the height. And so what's the length of Cindy's prism? Good, the length is 4 centimeters. Great work. What about the height? I'm sorry, the width. The width is 4 centimeters. What about the height of Cindy's box? That's right, it is 9 centimeters. So now that we have the information we need, length, width, and height, looking at the information in this diagram, we can find the volume. This gives me the dimensions I need. And so this time, let's use the formula. Volume equals length times width times height. Now, using the formula, what would your equation be? That's right. We could say that volume will be 4 times 4 times 9. 4 times 4 times 9. And so the first thing I'm going to need to do is find the product of 4 and 4. The product of 4 and 4 is, yes, 4 times 4 equals 16. And so 16 times 9. What is 16? What does the number 16 represent? Yes, the number 16 represents the base area, the area of this base. And I'm about to make it three-dimensional by multiplying by the height. What is the product of 16 and 9? Excellent, you are correct. 16 times 9 gives me a volume of 144. Keep in mind, we measure volume in, yes, cubic unit. And so my unit for this one is centimeters. So I'm going to say the volume of Cindy's box is 144 centimeters cubed. I could do the little 3, or I could write out cubic centimeters. Those are both accurate representations. Now here's a similar problem. Continue working along with me. I know you're doing so well. Susan needs a box to hold her erasers. She wants a box with a length of 6, the width of 6, and a height of 6. What is the volume of the box Susan wants to find? All right, so in order to find volume, we need to identify what things? That's right, we will need to identify length, width, and height. Can you do that? On your paper, can you write L, W, and H and identify those? Good. Did you say that the length of Susan's box was 6 inches, the width was 6 inches, and the height was 6 inches? Great job. Now that we know the dimension, what will we have to do with them to find the volume? You're right. We can use our formula to multiply. Now, I have a question before we do that. This figure is a rectangular prism, but do you know what else we could call this figure? Yes, it's also called a cube. Why can I call this rectangular prism a cube, but I cannot call this rectangular prism a cube? You're right. All the dimensions on this figure are not equal, but all the dimensions on this figure are. So a cube is a special rectangular prism that has all equal sides. We've been talking about unit cubes. Is this a unit cube? It is not a unit cube because in order to be a unit cube, your dimensions have to be 1. Good job. I just wanted to review that very quick. So now we know we can use the formula to find the volume. So let's use length times width times height. What did we say the length was? 6. Width, 6. Height, 6. Now we're going to do length times width is, that's correct, I heard it, 36. Can you tell me what that 36 represents? Yes, you're catching on quick. That 36 represents my base area. So 36 and a height of 6. So can you find the product of 36 and 6? Did you say 216? 216? That is correct. And you'll notice we were very careful on this one to make sure we wrote it in cubic inches because volume is measured using cubes. How many cubes will fit inside of this figure? So if I were going to decompose this and put a whole bunch of these inside, how many of these cubes would I be able to take out of this box? That's right. I'd be able to take 216 cubic units out of the box. Phenomenal work. Now let's continue solving. I can arrange. Now this one's a little bit different because there is no visual. We just have to pay attention to what the problem is telling us. And so I can arrange 1 centimeter unit cubes in the base of a box. Well, if they are 1 centimeter unit cubes, they have a volume of 1 cubic unit. So I'm arranging cubic units in the base of a box. The box has 4 rows of 5 cubes without any gaps. And so this sometimes is it okay to draw a picture to help you with this? Absolutely. We know that the 4 rows and each row has how many cubes in it? 5. And so this is like the base area. Excellent. And the height of our box is 5 inches. What is the volume of the box? So how can I use a formula to help me solve this problem? What would our equation be? Okay, I heard that you can multiply the number of rows and columns on the base to give us the base area times the height. Good thinking. So we would do length times width times height. Is that what you're saying? Excellent. And so our base area would be 4 times 5 is 20 times a height of 5 says that this box would have a volume of what? Yes, 100 cubic centimeters. Do you see the base area of 20 based on what it said? 4 rows, 5 cubes in each row. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our base area was 20. Now it's your turn to solve one on your own. After you've worked for a few minutes, we'll come back and we'll check it together. Are you ready? Great. Here's your problem. John's father is installing an aquarium. The base of the aquarium is 12 feet long and 4 feet wide. The height of the aquarium is 4 feet. How many cubic feet of water is needed to completely fill the aquarium? Find the volume of the aquarium or of this rectangular prism. You're working so hard. Take about 30 more seconds. All right. Are you ready to check your work? Great. Did you use the formula volume equals length times width times height? Good. Then your equation should have looked like this. 12 times 4 times 4. What is the product of 12 times 4 times 4? Did you say that 12 times 4 is 48? And that 48 times 4 gives us a volume of what? 192. Excellent. Did you say the volume of John's father's aquarium is 192 feet cubed? Is that the only formula that we could use? You're absolutely right. I heard somebody say, well, Miss Williamson, I use volume equals base area times height. That one also can be used. Remember though, how do we get that base area? Yes, you're right. We find the base area by multiplying the length and the width. And so when I multiply the length and the width, 48 is my base area. So we also could have said 48 times 4, which would have given us the same product or the same volume as this other formula because they're connected. Length and width does give me the base area. And so the volume, once again, is 192 cubic feet. Excellent work. I think we have time for one more. Are you ready? Same thing. I'm going to give it to you and let you work, and then we're going to come back and we're going to discuss it together. You'll have about 2 minutes. Are you ready? Can you find the volume of this rectangular prism? You've got about 30 seconds. Keep up the hard work. Okay, let's start. Did you start by using the formula length times width times height, or volume equals base area times height? What's the length of this prism? You're right, the rectangular prism has a length of 6 and a width of 4. And remember, length times width gives us our base area. So if we use this formula, we would have said the base area of this prism was 24 feet squared. Why is it two-dimensional? Because we haven't included the height yet. Now, if we use this formula, length times width times what was the height of our prism? Yes, excellent work. The height was 8. And so 6 times 4 is 24 times a height of 8. Are you seeing the connection between the two formulas? I hope you are. And then 24 times 8 was what? The product of 24 and 8. 8 times 4 is 32. I put a 2 in the ones place, regroup a 3 because it's worth 10, 30. 8 times 20 is 160 plus the 30, 160, 170, 180, 190 to give me a volume of 192 feet cubed. And so we can say the volume of this box is 192 cubic feet or feet cubed. Now I have a question because the last line we did also had a volume of 192. But what do you notice about the dimensions? That's right. The length and the height are different. And so remember, it's possible to have two different looking rectangular prisms that have the same volume. Okay. Great work, boys and girls. Today we reviewed solving for volume using rectangular prisms. I hope you're seeing connections to area and volume. You sure did a great job. After the video, you will have some problems to practice on your own. I will show you your independent practice problems now. You can also find these practice problems in the student practice section of the website at www.tn.gov/education. Good luck on your independent practice, and I know you will do your best. I've enjoyed reviewing the formulas to calculating volume with you today of rectangular prisms. Thank you for inviting me into your home, and I look forward to seeing you in the next lesson in the Tennessee's at Home Learning Series. Bye.